Hello, we're going to go through this problem the same way we did the others today. We have two fractions, and when we divide by a fraction, we multiply by the reciprocal. So I'm going to rewrite this fraction, and I'm going to copy the numerator exactly as it is, as 11 minus w over 30 w squared. And now instead of division, we're going to write it as multiplication. And now my denominator, we are going to take the reciprocal because when we divide by a fraction, we multiply by the reciprocal. 5w to the sixth over w minus 11. Okay, so now I'm noticing we have 11 minus w and w minus 11. They're almost exactly the same except for the positives and negatives. Sometimes that's a little easier to see if I write them, just switch the order, and I can do that because of the commutative property. So what I mean by that is I'm just going to rewrite it so you can see what I mean visually as negative w plus 11. It's the same thing. I'm just switching the order over 30 w squared times 5 w to the sixth over w minus 11. Now I'm going to think of this as I can almost cancel them out except I have the positives and the negatives. And it's sometimes easier to see if I factor out a negative 1. Because if I do that and think of it like a greatest common factor, I'm left with w minus 11. And now they're going to be exactly the same, the factors. And we can see how those two cancel out and we're left with a negative 1 over 5w to the sixth over w minus 11. So this will simplify. And then I'm going to see, is there anything else that can simplify? Well, I have 5 and 30. I can cancel that and be left with a 6 because 5 and 30, that can reduce to a 6. And now if I look at my exponents, I have off to the side w to the sixth over w squared. And then when we divide with exponents, we're going to subtract. So we'll be left with w to the fourth. And that will leave me w to the fourth. So now I have negative 1 w to the fourth over 6. Or you could just leave it as negative w to the fourth over 6. And that's as simplified as this problem can get. When I have quadratics or polynomials in my numerator and denominator, the first thing I want to do is factor. Because when I have factors, then I can see if anything can cancel out. So I'm going to first look and see what I can factor in this problem. And I'm noticing to start off, I have two perfect squares with a minus in the middle, so that's going to be the difference of squares. So we're going to start off by factoring with 5 minus 2x, and then 5 plus 2x. And then I'm looking at the denominator, and before I even try to factor anything, I'm going to think, always see if there's a greatest common factor first. So I do have a greatest common factor. I'm going to just do that first. Greatest common factor will be a 3. Then I'll have 2x squared plus 3x minus 5. I'm going to do this one step at a time. So, good reminder, let's check for greatest common factors. And we have another one in the next numerator, greatest common factor of a 2. And then we're left with 3x squared minus x minus 2. And still checking for greatest common factors. We do not have a greatest common factor, so we can go ahead and factor that. And you can factor this any method you want. When we factor this, we are going to be left with x plus 2 and then 2x minus 5. We have a lot of factoring in this problem. Okay, so we've already factored our first numerator. We have a greatest common factor. It is one of our factors in the denominator, so we are going to leave all of our factors and copy them down. And then just copying down my numerator right now. I want to leave my greatest common factor in the denominator. Now I need to factor that quadratic, and that's going to be 2x plus 5, and then x minus 1. Then we have 2 over here. We have to factor that quadratic as well. I have that. It's going to be 3x plus 2. And then this is going to be x. Oops, sorry, that's not x plus 1. It's going to be x minus 1. And then we've already factored x plus 2 and then 2x minus 5. So now everything is factored. Now I want to see if I can cancel out any of my factors. So I have a pair x minus 1 in my numerator, 1x minus 1 in the denominator. That cancels out. And now I'm going to see, is there anything else that can cancel out? So just to make it visually, I'm going to keep things in the same order. I'm going to switch my first numerator. I'm just going to switch the order, the commutative property. We can change the order. So I'm going to say negative 2x plus 5. And I want to be really careful with my signs. And then 2x plus 5 here. All I'm doing is switching my order. And then 3, 2, x plus 5. And now I'm copying everything else down that I haven't already canceled out. 2, and here I'm going to have 3x plus 2. And now x plus 2. And now 2x minus 5. Okay. I have 2x plus 5 in my numerator, 2x plus 5 in the denominator. They cancel out. So now we have a 2x minus 5 in the denominator over here. And then I have a negative 2x plus 5 over here. So everything's the same except the positives and negatives. So that I can cancel those out, but I'm going to be left with a negative 1. And if you have a difficult time seeing that, it's like saying we take out a negative 1 and then we're left with 2x minus 5. Because that's basically like saying we're taking out the negative 1 and we're having 2x minus 5 there. And that's why those two cancel out. So now we have negative 1, and I have over here times 2, 3x plus 2 over 3, and then x plus 2. And that, I'm going to just neaten it up a little bit as negative 2, parentheses, 3x plus 2 over 3, parentheses, x plus 2. And that's as simplified as this problem can become.